A pleasant day, everyone. I am Luis Albert E. Aban, and in this video, I am going to discuss the Chapter 11 in the Operating System course, and the topic is all about the mass storage structure. So, in this chapter, we began a discussion of file systems at the lowest level, the structure of secondary storage. We first described the physical structure of magnetic disk and magnetic tapes. We then described the disk scheduling algorithms which schedule the order of disk input or output to maximize performance. So in this chapter, ma-discuss daw natin yung the physical structure of magnetic tapes and magnetic disk. So we can also tackle here the different disk scheduling algorithms which naka-order na daw siya sa disk, which is na under siya sa input or output nga mga devices to maximize performances. So our chapter objectives first is to describe the physical structure of secondary storage devices and its effects on the uses of devices. Second is to explain the performance characteristics of mass storage devices and to evaluate these scheduling algorithms. And last is to discuss operating system services provided for mass storage, including RAID, R-A-I-D. So, overview of mass storage structures. So, in this section, we present the general overview of the physical structure of secondary and tertiary storage devices. Magnetic tapes, magnetic disks provide the bulk of secondary storage for modern computer systems. Conceptually, disks are relatively simple. So, as what you can notice here in the picture that I will be going to provide in my presentation, there is a picture there of the magnetic disk, and in the first row, or in the first in the upper side, we have the track, the what we call this, the spindle, and in the second corner we have the sector, and the cylinder, the platter, the arm, and the rotation of the magnetic disc. And also we also have arm assembly. So a read-write head flies just above each surface of every platter. The heads are attached to a disc arm that moves all the heads as a unit. So the surface of a platter is logically divided into circular tracks, which are subdivided into sectors. The set of tracks that are at one arm position makes up a cylinder. There may be thousands of concentric cylinders in a disk drive, and each track may contain hundreds of sectors. The storage capacity of common disk drive is measured in gigabytes. So, lahat daw ng storage na capacity nga siya into sa disk, kay na-measure daw siya into gigabytes. So, we all know gigabytes is pila ka zero. When we say giga, it is 9 zeros. So, a disk can be removable, allowing different disks to be mounted as needed. Removable magnetic disks generally consist of one platter held in a plastic case to prevent damage while not in the disk drive. Other form of removable disk includes CDs, DVDs, and Blu-ray discs, as well as removable flash memory devices known as flash drive, which are a type of solid-state drive. So, other form daw sa removable disc, kaya ginatawag siya nga CD, or what we call this, the compact disc, the DVD, or yung display video na disc, and also the Blu-ray disc, and also makonsider gyapon siya ang flash memory devices ginatawag natin siya commonly known as flash drive. So, as what you can observe, there is still a lot of people know that still calling the flash drive as universal serial bus, but it is not. It should be flash drive. So, solid state disk. Sometimes all technologies are used in new ways as economic change or the technologies evolve. An example is the growing importance of solid state disk or SSD. Simply described, an SSD is non-volatile memory that is used like a hard drive. There are many variations in this technology, from DRAM with a battery to allow it to maintain its state in a power failure through flash memory technologies like single-level cell or SLC and multi-level cell or MLC chips. SSDs have the same characteristics as traditional hard disk but can be more reliable because they have no moving parts, and faster because they have no seek time or latency. In addition, they consume less power. However, they are more expensive per megabyte than traditional hard disks, have less capacity than the larger hard disk, and may have shorter lifespans than hard disks, so their uses are somewhat limited. One use for SSDs in a storage arrays where they hold file system metadata that require high performance. SSDs are also used in some laptop computers to make them smaller, faster, and more energy efficient. So, ang SSD daw guys is ginagamit gyapon siya sa mga laptop computers to para para malimit magamay ang iyahang capacity and faster, and at the same time and also more para maka siya og energy nga more efficient. So next is magnetic tapes. So when we say magnetic tapes guys, we already know that it is a secondary storage medium. So although it is relatively permanent and can hold large quantities of data, its access time is slowed compared with that of main memory and magnetic disk. In addition, random access to magnetic tapes is about 1,000 times slower than random access to magnetic disk. So tapes are not very useful for secondary storage. So hindi daw kaayo siya useful for secondary storage kay ang magnetic tape daw is 1,000 times slower than random access to magnetic disk. So tapes are used mainly for backup. So backup lang daw siya. For storage of infrequently used information and as a medium for transferring information and from one system to another. So a tape is kept in a spool and is wound or rewound past a read-write head. Moving to the correct spot on a tape can take times, but once positioned, tape drives can write data at speed comparable to disk drive. Tape capacities vary greatly, depending on the particular kind of tape drive, with current capacities exceeding several terabytes. So, we all know naman na ang magnetic tapes is secondary storage medium siya. So, disk structure. Modern magnetic disk drives are addressed as large one-dimensional arrays of logical blocks, where the logical block is the smallest unit of transfer. The size of a logical block is usually 512 bytes. Although some disks can be low-level formatted to have a different logical block size, such as 1024 bytes. This option is described in section 10.5.1. The one-dimensional array of logical blocks is mapped onto the sectors of this sequentially. Sector 0 is the first sector of the first track of the outermost cylinder. The mapping proceeds in order through the track, then through the rest of the tracks that in the cylinder, and then through the rest of the cylinders from outermost to innermost. So, as what I have mentioned earlier about the disc structure, alam naman na natin na napakita ko sa recent ko na slide yung about sa structure ng isang disc. So, next is disk attachment. Computer access disk storage in two ways. One way is via input or output ports or host-attached storage. This is common in small systems. The other way is via to remote host in a distributed file system. This is referred to as network-attached storage. So when we say host-attached storage host, it is a storage access through local input or output parts. So, a host attached daw nga storage host, consider daw natin na siya as input or output local ports. These ports use several technologies. The typical desktop PCs use in a input or output bus architecture called IDE or ATA. This architecture supports a maximum of 2 drives per input or output bus. A newer similar protocol that has simplified cabling is SATA, SATA. So, a wide variety of storage devices are suitable for use as host-attached storage. Among these are hard disk drives, RAID arrays, and CDs, DVD, and tape drives. The input or output commands that initiate data transferred to a host-attached storage device are reads and writes of logical data blocks directed to specifically identified storage units such as bus ID or target local unit. So, next, we have the network-attached storage. So, when we say, as what I have mentioned, there are two way of to access the disk storage computers. So first is the host attached storage host, and the second is the network attached storage. So when we say network attached storage, it is a network attached device. It is a special purpose storage system that is accessed remotely over a data network. So ma-attach daw siya remotely. So ma-control natin siya. So clients access network attached storage via a remote procedure called interface such as NFS for Unix system or CIFs for Windows machines. The remote procedure calls or RPC are carried via TCP or UDP over an IP network, usually the same local area network or LAN that carries all data traffic to the clients. Thus, it may be easiest to think of NAS as simply another storage access protocol. The network attached storage unit is usually implemented as a RAID array with software that implements the RPC interface. So, yon, the keyword of a network attached storage is remotable, remotely accessed over a data network. So, ma-access daw siya through pag-control sa iyahang data. So, next is, I will just attach here the mass storage structure, the LAN, local area network, and the wireless area network. So, when we say LAN, as, diba, we are already familiar with LAN and WAN when we are connecting into Wi-Fi or sa mga data, mga hotspot. Yun yung tinatawag natin nga wireless or LAN. So, network attached storage provides a convenient way for all the computers on a LAN to share a pool of storage with the same ease of naming and access enjoyed with local host attached storage. So, however, it tends to be less efficient. and have a lower performance than some direct attached storage options. ICSCI is the latest network attached storage protocols. In essence, it uses the IP network protocol to carry the SCSI protocol. Thus, networks rather than SCSI cables can be used as an interconnect between hosts and their storage. As a result, hosts can be treat their storage as if it were directly attached even if the storage is distant from the host. So, ano daw, amo to ang kinamin natin nga LAN kag wireless area network. Yon. Storage area network. One drawback of a network attached storage system is that the storage or input or output operations consume bandwidth on the data network, thereby increasing the latency of network communication. This problem can be particularly acute in large client-server installation. The communication between servers and clients competes for bandwidth with the communication among the servers and the storage devices. So, ang storage area network daw guys, ginagamit siya to consume bandwidth on the data network. Kumbaga, ginagamit siya para makakonsume ta sang storage na ginagamit naton sa isa ka data. So, it is a private network daw, using storage protocols rather than a networking protocols, connecting servers and storage units as shown in the figure 10 that I will just attach here in this video. The power of SAN lies in its flexibility. Multiple hosts and multiple storage arrays can attach to the same SAN, and storage can be dynamically allocated to hosts. A SAN switch allows or prohibits access between the host and the storage. As one example, if a host is running low on the disk space, the SAN can be configured to allocate more storage to that host. SANs can make it possible for clusters of servers to share the same storage and for storage arrays to include the multiple direct host connections. So, okay. So, next we have the disk scheduling. So, we're already familiar with disk scheduling as what we have already tackled to a first chapter in this course, which is the operating system introduction, which is tackled by Ma'am Mela Flor, the disk scheduling. We're already familiar with this because she already discussed it and introduced it. So when we say disk scheduling, one of the responsibilities of operating system is to use the hardware efficiently. For the disk drive, meeting the responsibility entails having fast access time and large disk bandwidth. For magnetic disk, the access time has two major components. As mentioned on the previous topics, the seek time is the time for the disk arm to move the heads of the cylinder containing the desired sector. The rotational latency is the additional time for the disk to rotate the desired sector of the disk head. The disk bandwidth is the total number of the bytes transferred divided by the total time between the first request for service and the completion of the last transfer. There are types of disk scheduling. First is the FCFS scheduling. Second is the STF scheduling. Third is the SCON scheduling. Fourth is the CSCON scheduling. Fifth is the LOOK scheduling or LOOK. And last is the selection of the disk scheduling algorithm. The summary of my report for in this video. Disk drive are the major secondary storage input or output devices in most computers. Most secondary storage devices are either magnetic disk or magnetic tapes. So we are already discussed the difference between in this chapter we already discussed the difference between the magnetic tapes and magnetic disks, Although solid-state disks are growing in importance, modern disk drives are structured as large one-dimensional arrays of logical disk blocks. So generally, these logical blocks are 512 bytes in size. These may be attached to a computer system in one of two ways. One is through local input or output ports of the local host computer, and the second through a network connections. Requests for this input or output are generated by the file system and by the virtual memory system, and each request specifies the address and the disk to be referenced in the form of logical block number. These scheduling algorithms can improve the effective bandwidth, the average response time, and the variance in response time. Algorithms such as SSDFS, TF, SCAN, CSCAN, LOOK, and CLOOK are designed to make such improvement through strategies for this queue ordering. For performance of these scheduling algorithms can be varied greatly on magnetic disk. In contrast, because solid-state disks have no moving parts, performance varies little among the algorithms, and quite often a simple FCFS or first-come first-served strategy is used. Performance can be harmed by the external fragmentation. Some systems have utilities that can the file system to identify fragmented files. They can move blocks around to decrease the fragmentation. Defragmenting a badly fragmented file system can significantly improve performance, but the system may have reduced performance while the defragmentation is in the progress. Sophisticated file systems such as the Unix fast file system incorporate many strategies to control fragmentation during space allocation so that this reorganization is not needed. So that ends with my report for this video, and I hope you learned something for this video, and good evening, a good day again, everyone. Thank you for listening.